All right. We're going to try to finish chapter 3 today. We're going to try to do these 3 sections. 3.2 is the least common multiple. Section 3 is mixed numbers, adding and subtracting mixed numbers. And section 5 deals with the order of operations with fractions. However far we get. If not, then we'll finish it Monday and then we'll start chapter 4 also on Monday. So with the least common multiple method, with operations, there are 3 methods. We're going to go through all 3 different methods. You can choose whatever method you like when you solve these things. What is a least common multiple? It's the smallest number that all of the, I'm going to use the word test numbers, fit into, or divisible of. The smallest number that all these numbers that we're looking at, that they'll fit into. Example. LCM of 6 and 9. So what that's asking, what's the smallest number that 6 and 9 both fit into? The smallest number that 6 and 9 fit into. 6 doesn't fit in 3. But 6 times what is 3? See, that's what I'm saying is these numbers fit into, so it has to be something bigger. So what's that? 9 doesn't fit in 6. 18, yes. Well, so this is the first method we're going to look at. Are the multiples. So we have 6 and 9. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30. So this is multiplied by 1, by 2, by 3, by 4, by 5. 1 times 9 is 9, 2 times 9 is 18, 3 times 9 is 27, 4 times 9 is 36, 5 times 9 is 45. You see what I did there? All I did was multiply. These first numbers are 6 times 1, 9 times 1. 6 times 2, 9 times 2, 6 times 3. So I just made out the multiples. Then I look at what's the smallest number they both have. So the LCM of 6 and 9 is 18. Okay, here's another method. Prime factors. So what are the prime factors of 6? 2 and 3. How about 9? 3 and 3. So once you prime factorize your test numbers, it's easier if you circle what you have. So this one has a 2, so we need a 2. This one has 2 3s. So they both have 1 3. This has an extra 3. So I have 2 3s. So you look at what are all the sets of numbers that the factors have. So 2 times 3 is 6, times 3 is 18. And we'll do more difficult ones in a minute. Any questions about this one? I prime factorized it and I saw there's a 2 inside this list. There's at least 1 3. There are 2 3s in there. I don't have 3 3s. Why don't I have 3 3s? Because both of these are the same. They both have a 3 in common. But this one has an extra 3. So that's, you only put what's extra. The third method is divisibility. So the numbers 6 and 9. So I'm starting with you. Look at the first one. What number is 6 divisible by? 2. So 2 goes into 6 3 times. Is 2 divisible into 9? No, so I just write it down again. Repeat the process. What's 3 divisible by? So 3 goes into 3 1 time. 3 goes into 9 3 times. Okay, nothing. This is a number. So the next number is 3 goes into 3. How many times? 1 time. What your objective is, you want to get 1s on the bottom. As soon as you get 1s, you multiply these numbers. 2 times 3 times 3 is 18. Okay, let's look at another set of numbers. Let's look at 9 and 12. Let's get bigger numbers. Find the LCM of 9 and 12. Again, we're going to do all 3 methods. And then you could choose whatever method you want to when you do the homework. So the multiples, we have 9 and 12. 1, 2, 3, 4, 5. So 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. Twelve times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. Once you get to a point where you see this number and this number are equal, that's your LCM. LCM of 9 and 12 is 36. Everybody okay with that? The second method. Second prime. Yes.
What class is this?
DMAT. It's a math course.
All right, thank you.
Yes, sir. Prime factorization. Prime factorization of 9 and 12. 9 is made up of what? Three times 3. 12 is made up of 2 times 6, 2 times 3. So it's 2 times 2 times 3. So now we circle where all the numbers we have. We have a 2, another 2. This 3 and this 3 are the same. And then I have an extra 3. So the LCM of 9 and 12 is 2 times 2 times 3 times 3. 4 times 9 is 36. Divisibility. So with the divisibility, I just put the two numbers, 9 and 12. So what's the smallest number that fits into 9? 3. 3 goes into 9 3 times. 3 goes into 12 how many times? 4. So yeah, smallest number. 3 goes into 3 1 time. 3 doesn't go into 4, so I just bring it down. The smallest number that fits into 4 is, you say 4, but let's do it the long way. So 1 just goes into 1. 2, 4 divided by 2 is 2. And then likewise, 2 divided by 2 is 1. So I multiply all these numbers. Nine times 4 is 36. So which one of the three methods do y'all like the best? The first one, the prime factorization one? I mean, the multiple one? Let's try one with 3 numbers. Find the LCM of 12, 18, and 20. Twelve, 18, 20. One, two, three, four, 5. I hope we don't have to go any further than 5. So 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. 12 times 5 is 60. Eighteen times 1 is 18. 18 times 2 is 36. 18 times 3 is 54. 18 times 4 is 72. 18 times 5 is 90. Twenty times 1 is 20. 20 times 2 is 40. 20 times 3 is 60. 20 times 4 is 80. 20 times 5 is 100. So is there an LCM so far? No. So what does that mean? We have to keep on going. So we left off, so 6, 7, 8, 9, 10. 12 times 6 is 72. 12 times 7 is 84. 12 times 8 is 96. 12 times 9 is 108. 12 times 10 is 120. Eighteen times 6 is 108. 12 times 7, 126. 18 times 8, 144. 18 times 9, 162. 18 times 10 is 180. Twenty times 6 is 120. 20 times 7 is 140. 20 times 8 is 160. 20 times 9 is 180. Is 210. Do we have one yet? This is now, is the first method still your favorite? No. So we have to go further. Well, I'll tell you what, we'll come back to this one later. I'll show you why I don't. So what's the second method? Prime factorization. One 180, this one's 136, 148, 160, 172, no. 140, it's 144, 156, 168. Yeah, it's 180. So we have to go up to one more set. Because this one has 180, this one has 180, and the 12. We have 11, 12, 13, 14, 15. So 120 plus 12 is 132, 144, 156, 168, 180. So the LCM is 180. There's the drawback of the multiple one, because you may have to keep on going until you find something that's in common. Prime factorization. So what is 12 made up of? 12 is made up of 2 times 6. 6 is 2 times 3. So it's 2 times 2 times 3. 18 made up of 2 times 9. 9 is 3 times 3. So it's 2 times 3 times 3. 20 is 2 times 10. 10 is 2 times 5. So it's 2 times 2 times 5. All right, so let's look at these things. We have 2 2s that take care of. Those are taken care of. We have 2 3s, so that one's taken care of. And we have a 5. So the LCM is 2 times 2 times 3 times 3 times 5. 4 times 9 times 5. 4 times 9 is 36. 5 times 6 is 30. 5 times 3 is 15, plus 3 is 180. Pretty good so far? Let's do divisibility now. So we have 12, 18, 20. Look at the first one. What's the smallest number that fits into 12? 2. 2 goes into 12 6 times. 2 goes into 18 9 times. 2 goes into 20 10 times. What's the smallest number that goes into 6? 2. 2 goes into 6 3 times. 2 doesn't go into 9. 2 goes into 10 5 times. What smallest number fits into 3? 3. 3 goes into 3 once. 3 goes into 9 3 times. 3 does not go into 5. So that one's already finished. So it just comes down as a 1. Smallest number fits into 3 is a 3. 3 goes into 3 one time. 3 does not go into 5. So these are taken care of. Smallest number fits into 5 is 5. 1, 1, 1. That's what you're looking for. So the numbers we multiply together are 2 times 2 times 3 times 3 times 5 equals 180. So now what's the easiest method? Big divisibility? I kind of like the LCM, the prime factorization one. But yeah, divisibility also, if you understand it, it works because it's nice and clean. All right, so that's what section 2 is about, LCMs. Section 3. Adding, subtracting of mixed numbers. We have two methods here. Okay, when we talk about mixed numbers, what are we looking at? What do they look like? What does a mixed number look like? Yeah, it has a number and a fraction. This number is actually made up of an equation. This number is the same thing as that. We can separate them by putting a plus between them. Also, another thing I need you to remember, 1 is any number divided by itself. Because now with these two sets of rules, we can do our section. 3 1/2 plus 5 2/3. In your homework, you're going to be asked to do two numbers here, two solutions. One's going to be an estimate and one's going to be a solution. So with an estimate, 3 1/2. Let's round it as either up or down. Do we go up or down at 3 1/2? Up, yeah, because anything from 0.5 on up, we go up. Anything from 0.4 down, we leave it alone. Just drop it. So this one rounds up to 4. 5 2/3 goes up around to 6. So if we add those two together, our answer should be around 10. Give or take some numbers. So far, so good? Because this is just either you round up or just leave it alone. Since both of those were closer to the higher numbers, we went up. Now, when you do these, the first thing we do is we add the integers. Then we add the fractions. Three plus 5 is 8. We could do the butterfly method here. So that's 4. That's 3. And we add them. 2 times 5 is 10. So we have 3 plus 4 over 10. So there's your exact answer. You just separate the numbers, put it in two parts, and then combine them at the end. Let's look at another one. 6 7/8 plus 2 1/4. So we set it up this way. I mean, we don't have to. It's just we add the numbers. Well, first off, 6 7/8. Do we go up or just drop the decimal? Is 7/8? Is that bigger than 0.5? Yeah, so this one goes up to 7. 1/4. Is that bigger than 0.5? No, so we just drop it. We stay down at 2. So this answer should be around 9. So add the integers, then add the fractions. That's 8. 7 times 4 is 28. So I have 28 plus 8. 8 times 4 is 32. Because all I did here was do the butterfly method. If you want me to do it over here, I can. Is everybody okay with the butterfly method? So we have 8. 28 plus 8 is 36/32. What's wrong with 36/32? It's an improper fraction. So we have, how many times is 32 going to 36? One time with how many left over? Is everybody okay with this so far? So we have 8 plus 1 plus 4/32. Eight plus 1 is 9. Can this simplify any further? How many times does 4 go into 32? And that's not be 36. Yeah, so 4 goes into 1/4. 32 8 times. So the answer is 9 1/8, which is pretty close to our estimation. I apologize that I crammed it in the very bottom of the sheet. I didn't think it was going to take that much space. Want me to redo it on the next page? Or is everybody okay? Let's look at subtraction problem. 4 7/8 minus 2 2/3. Let's first look at the estimation. So 4/7/8. Does it go up to 5 or does it drop to 4? Is 7 divided by 8 bigger than 0.5? Yeah, so it goes up to 5. Likewise, 2/3 is bigger than a half, so it goes up to 3. 5 minus 3 is 2. So there's our estimate. Our answer should be pretty close to that. That's our estimate. So it's 4 minus 2 plus 7/8 minus 2/3. Or it's always plus when you separate the integers from the fractions. 4 minus 2 is 2. So here we have 7/8 minus 2/3. There's a minus sign there. So 3 times 7 is 21. 8 times 2 is 16. So it's 21 minus 16. 8 times 3 is 24. (21 minus 16 is 5. So the answer is 2 5/24. 5/24 is pretty small, so it's pretty close to 2. So that's a good estimate. You're very good so far. Let's do another one. 15 4/5 plus 2/3. So let's look at the estimates here. Yes. 4/5. Is that bigger than 0.5? Yes, because it's almost 1. So we rounded up to 16. 2/3. Is that bigger than 0.5? That's 0.6. So round that up to 1. So 16 plus 1 is 17. That's our estimate. So we just have 15, since there's nothing else to add it to. And then we add the fractions. 4/5 plus 2/3. So 3 times 4 is 12. 5 times 2 is 10. 5 times 3 is 15. So we have 12 plus 10 over 15. (22 over 15). 22 over 15 is an improper fraction. How many times is 15 going to 22? Once, with how many left over? 7, yeah. 15 plus 7 is 22 over 15. So we add 15 plus 1 gives us 16 plus 7 over 15, which is 16 7/15. So far, so good? Is anybody still confused? Because now I'm gonna get to a question where you guys should have a question about. It has to do with subtraction. If the bottom fraction is bigger than the top fraction, you have to borrow something. So this is what we have to do. Okay, so finished. So we have 8 1/3 minus 4 3/5. Here's our estimate. So we have 8 1/3 minus 4 3/5. So what number goes here? Why? Yeah, 1/3 is less than 0.5. So this is just 8. What number goes here? Yeah. Because 3/5 is bigger than 0.5. So we add 1 to 4. So 8 minus 5 is 3. There's our estimate. Eight minus 4, 1/3 minus 3/5. We can never have a negative answer inside here. We can never have a negative answer inside here. In other words, whatever's in front has to be bigger than whatever's behind it. Is it? No, because if we look at this thing, What's the smallest number 3 and 5 go into? What's the LCM of 3 and 5? 15. So 3 times 5 is 15. So 5 times 1 is 5. 5 times 3 is 15. 3 times 3 is 9. 5 minus 9 is -4. We can't have that. So how do we make this number bigger? In other words, we have to make this fraction bigger. We do that by borrowing 1 from 8. So 8 1/3 becomes 7 plus 1 plus 1/3. Make that into a fraction. Remember we talked about in the first page? What is 1 equal? Or any number. So since the denominator is 3, we have to have 3/3. Since the denominator here is 3, this one has to be 3/3. Three plus 1 is 4. So this is the number we have to use then. Instead of 8 1/3, we have to use 7 4/3. So if this number is negative, then do that. Take leading coefficient, split it up into 2 numbers, plus 1. Make that 1 whatever the denominator is, and then work it out. Because now what do we have? We have 7 minus 4 plus 4/3 minus 3/5. Four minus 3 is 3. Three times 5 is 15. 5 times 4 is 20. 3 times 3 is 9. So it's 20 minus 9/15. 11/15. There's your answer. The fractions cannot make the answer negative. Only the numbers in front can make it negative. The coefficients. That's okay, because remember, originally, it was going to give us a negative answer. This is going to give us -4/15. We cannot have that. So we have to make the first number, we have to make this fraction bigger. When we added 1 to it, we made it bigger. Now we could put it inside the equation and it's going to be positive. It doesn't matter now. At that point, because we did it on, it wasn't a final answer. It was, we did that on purpose. We did that on purpose when we added 1. Because once you add 1 to this fraction, it's automatically gonna be bigger than 1. Because 1 plus anything is bigger than 1. It's gonna be an improper fraction. But we need it that way so that it's a positive answer. Yeah, so if you ever do this and you have a negative answer in the fractions, go back and subtract 1 from your coefficient and add it to the fraction. So that's the first way of adding mixed numbers or subtracting them. The second way convert to improper fractions. Add or subtract. Then put back into mixed number. Nine and 2/3 plus 7.5. So our first step is to take both of these guys and put them into improper fractions. Remember how to do that? Take the coefficient, multiply by the denominator, then add the numerator. So 9 times 3 is 27. So it's 9 times 3 plus 2 over 3. 7 times 2 plus 1 over 2. This times the bottom plus the top. This times the bottom plus the top. 27 plus 2 over 3. 14 plus 11 over 2. (29 over 3). 25 over 2. Then we could do our butterfly. (25 times 3 is 75. The sign is plus. 29 times 2 is 58. 3 times 2 is 6. 58 plus 75 over 6. So we have 75 plus 58. 8 plus 5 is 13. 7 plus 5 is 12, plus 1 is 13. So it's 133 over 6. Okay, we ended up with an improper fraction. So now let's put it back. How many times does 6? How many times does 6 go into 13? 2 times. 2 times 6 is 12. And put a 0 there. 13 minus 12 is 1. Bring down to 3. 6 goes into 13 2 times. So the answer is 22 1/6. That's all that part is convert from the mixed numbers to improper fractions, do the math, and then convert from improper fractions back to mixed number. Is that okay?
Where did you?
Where did I get 6 from? 1/6. When I had this, the remainder goes on top. This goes on top. The denominator is whatever I divide by. Okay, so that's that. We should remember how to convert from mixed number to improper and then improper to mixed number. That's the only hard part about it. You want to do another one or you're okay with it? One more? All right. Let me see. Let's do subtraction. 4/7/8 minus 2 2/3. Pause this. All right, so let's convert this one from mixed number to improper. So it's 4 times 8 plus 7/8. So it's 2 times 3 plus 2/3. Four times 8 is 32. 2 times 3 is 6. 32 plus 7 is 39. 6 plus 2 is 8/3. Do the butterfly. 3 times 39. 9 times 3 is 27. 3 times 3 is 9, plus 2 is 11. 8 times 8 is 64. 8 times 3 is 24. So we have 117 minus 64 over 24. One 117 minus 64. 7 minus 4 is 3. 11 minus 6 is 5. Two times 24 is 48. 53 minus 48 is 5. So our answer is 2 5/24. So far, so good? Is everybody kind of okay with it? It just takes practice. We could do another if you want to. The hardest part of these is your multiplication tables. That's the hardest part. All right, let's look at 3.5. Order of operations and exponents. Let's first look at what do these two signs mean? What does this one mean? This is less than. Remember, you read math from left to right. This number is smaller than this number. This number here, the sign here is greater than. So it always points to the smaller and it's open to the bigger. And you always read left to right. So this number is less than this number is greater than this number. So that's how you read the signs. Now, how do we compare fractions? Oh, it makes 15. 13 over 8. What sign goes here? Less than or greater than? And we don't take guesses here. You have to prove to me why. The thing about the question of math is why. The only way you can compare fractions is how? You can only compare fractions if they have the same denominator. Bottom number. Because the bottom number tells us how many pieces we have. And the top number tells us out of those pieces, how much are we taking? This is where the whole concept of the LCM comes into being. I don't know yet. We'll figure it out. So to get the bottom number to be the same, this side, we have to multiply this denominator. This side is 9 over 9. Nine times 8 is 72. So they both have the same number on the bottom. Thirteen times 9. 9 times 3 is 27. 9 times 1 is 9 plus 2 is 11. 15 times 8. 8 times 5 is 40. 8 times 1 is 8 plus 2 is 12. We did 5 times 8 here. We did 19 times 3 here. Now, once you have the bottom numbers the same, you only have to compare the top numbers. Is 117 bigger than 120? No, so it's less than. See, there should be no reason ever to get these kind of questions wrong. If you do this. Do this one. So I take this denominator and multiply it to top and bottom here. I take this denominator and multiply it to the top and bottom here. Three times 4 is 12. 3 times 4 is 12. So we have a common denominator. On top, 9 times 3 is 27. 7 times 4 is 28. Is it less than or greater than? Right. So I take whatever I have in the bottom here, multiply it to top and bottom there. Whatever's the bottom here, take bottom. I did that because they're small numbers. What if I had bigger numbers? So you have to ask yourself, what's the smallest number that 10 and 15 both fit into? No, they have to fit into. 5 fits into 10 and 15, but does 10 fit into 15? We have to find the LCM. What's the smallest number that both 10 and 15 fit into? So this is 10, 20, 30, 40. This is 15, 30, 45. So 30 is the smallest number they fit into. So for this one to equal 30, what do I have to do? For this first side, 10 times 3 is 30. So I gotta do it on top also. 27. 15 times what is 30? 2. So I put 2 and 2. This is 1, 2, 3. So I multiply 15 times 2 to get 30, 10 times 3 to get 30. This is the reason we went through the LCM. You have to find out what those are first. And on Monday, I'll show you another form of doing these inequality things. Because the last thing we're gonna do today is if I have fractions raised to a power, what does this thing mean up here? What does that exponent mean? If I had a to the third, what does that mean? Yeah, so it's a times a times a. I multiply the base this many number of times. So what this thing means is 1/2 times 1/2 times 1/2. So I multiply straight across. 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8. Okay, this is one way you can do it. You can expand it this way and just multiply top, top, bottom, bottom, bottom. Or you could distribute that power, this exponent, to both top and bottom. So it's 1 times 1 times 1, 2 times 2 times 2, which is 1/8. What was this one? What's this one going to be equal? And this we'll call it a day. What's that one going to be equal? Yep. So I take this 2 and put it on top of each number. So 5 times 5, 8 times 8. So it's 25/64. There's your answer. And we can't simplify any further because if we could, we would have done it here. We'd simplify here before we use the exponent. All right, we'll continue here on Monday. And we'll finish up because the next part is we're going to combine everything, adding, subtracting, and exponents. It gets to look really ugly.